Okay, our objective for today is to look at Venn diagrams and how they relate to conditionals, their inverses, converses, and contrapositives. So a lot of new vocabulary here today, but I'm going to explain it all. So what is a Venn diagram? Well, you probably remember what the traditional types look like. You got one ellipse intersecting another. This shows people that like Coke and people that like Pepsi. So some people like Coke and Pepsi, and we would call this an intersection. C intersects P. So where are the people that like Coke and Pepsi? Well, they're in here, obviously. That's the intersection. So the intersection is what they have in common, what the two sets have in common. Now, if you look at Coke or Pepsi, that would be the union, and it's just the same symbol flipped upside down, so it's a U. And it's easy to remember. This looks like an N for intersection. This looks like a U for union. Um, so the union, where would those people be? The people that like Coke or Pepsi? Well, it's everybody, because these people like Coke or Pepsi. They like Coke. And these people like Pepsi, so they like Coke or Pepsi. These people like both, so they like Coke or Pepsi. Now, what we're going to be doing in this section is looking at subsets, really. So you have the set of mammals, and within that set, you have the set of cows. So you could say a conditional, if it is a cow, then it is a mammal. And that makes sense, because every cow is a mammal. But if you look at the converse of that, it doesn't really work. If it is a mammal, then it is a cow. The converse is when you flip it around. So what I'm going to be showing you here is that there really is no relationship between a converse and its conditional. And we'll look more about what inverses are and contrapositives are in a minute. Okay, so let's try intersection versus union. We're going to try A intersect B with these two sets. So what do they have in common? Looks like 5 and 7 is all they have in common. So that would be the intersection of those two sets. Now, union. The union, you got to put both sets together, but you don't want to count anything twice. It's like when a man and woman get married, they union, they bring everything together, everything they own. They may each have a toaster when they get married, but they're not going to have two toasters in their house, so they get rid of one. Same with a vacuum. If they both have one, you don't count it twice. You just take one of them. So A union B would be everything that's in set A, 1, 3, 5, 7, 9, and then also 6 and 8. And then that would be the union of the two. But don't count the 5 twice or the 7 twice just because it appeared twice. Set C we're going to add to it now. 7, 8, 9, and 10. What is A intersect B intersect C? So what you'll have to do first is what's in parentheses first. You follow the order of operations. B intersect C is what those two have in common. Looks like it's just 7 and 8. And then A intersected with that, the only thing that A has in common with 7 and 8 is 7. So that's that. And then finally, A union B intersects C. We already figured out what B intersects C is, 7 and 8. So if you put A together with that, it's 1, 3, 5, 7, 9, and then just add 8 to it. Okay, here's kind of a funny one. This is the rock with hair and no beard. Union, the rock with a beard. So you put it all together, and you get hair and a beard. But if you do hair intersect with a beard, they have nothing in common, and so you get a bald rock. Okay, we're going to start now talking about conditionals, their inverses, converses, and contrapositives. So this is just an abbreviation for a standard conditional. If P, then Q. Or you could also read it, P implies Q. So if it is an integer, then it is rational. Think about that a moment. Integers are the positive and negative whole numbers and 0. Rationals are any numbers that can be written as fractions. So if this is a set of integers, every integer is rational because every integer could be written as a fraction. 7 could be 7 over 1. Negative 19 could be negative 19 over 1. So that's a true statement. Okay. Now, the inverse is when you negate both of them. So you're saying if it is not an integer, then it is not rational. Now, is that true? If it is not an integer, it is not rational. Well, how about 3/4? 3/4 is not an integer, but it is rational. It is a fraction. So this is a false statement. So there's no necessary relationship between an inverse and its conditional. The conditional might be true and the inverse false. or the inverse could be true. You just don't know. Let's look at the converse. The converse is when you flip them around. So it's normally if P then Q. We're saying if Q then P. So we're saying if it is rational, then it is an integer. Well, that's not true either, because you could have a fraction of 1/2. It's rational, but it's not an integer. So that's also false. No relationship between a converse and its conditional. Let's look at the contrapositive. This is where you negate it and flip it. You do both. So if it is not rational, then it is not an integer. And that is true. And you're going to find that the contrapositive always matches the original conditional. If the original conditional is true, the contrapositive will be true as well. If the original conditional is false, the contrapositive will be false. And this is actually a way of proving stuff. Sometimes you can't prove your original conditional because you're having a hard time making this statement. So what you can do is prove the contrapositive true. And if the contrapositive is true, then that proves the original conditional true. It's a way of solving things, a way of proving things. So let's look at inverse versus converse, because a lot of times students get them confused, and I want you to be able to keep them straight in your head which one's which. One of them, there's negatives involved, and the other one flips. So this is how I think of it. When I see the negatives, I think inverse property of addition. The inverse property of addition says when you add a number to its opposite, you get 0. So a number and its opposite always makes 0. So inverse involves negatives. So that's how I remember the inverse is the one that has the negatives. Now converse, what I think about is basketball shoes. So this guy's wearing Converse basketball shoes, and he dribbles up and he does a reverse layup. He spins around at the last moment wearing Converse, and so that just reminds me, hey, converse is the flipping one. Okay, we're going to look at a couple conditionals here. If it has 3 sides, then it is a triangle. That is true. If he is human, then he is a mammal. True. So we're starting with 2 true conditionals. Let's look at the inverse. Inverse is where you make them both negative. So if it does not have 3 sides, then it is not a triangle. And that is true. If it doesn't have 3 sides, it's not going to be a triangle. If he is not human, then he is not a mammal. Well, that's false, because it could be a dog. So there's no relationship between an inverse and its conditional. Converse, you flip them around. If it is a triangle, then it has 3 sides. That is true. If he is a mammal, then he is a human. No, that's not true. That could be a whale. So again, no relationship between a converse and its conditional. Contrapositive. That's where you negate and flip. If it is not a triangle, then it does not have 3 sides. True. If he is not a mammal, then he is not human. That's also true. And again, always matches the original conditional. If the original conditional is true, the contrapositive will be true. Okay, last one we're going to look at here. If angle ABC is acute, then the measure of angle ABC equals 57. Well, that's false. So now we're looking at a false conditional. Just because it's acute doesn't mean it has to be 57. It could be 42. So the inverse now. If I negate it, what happens? If angle ABC is not acute, then the measure is not 57. I think that's true. If it's not acute, how could it be 57? So that's a true statement. Once again, no relationship between an inverse and its conditional. The converse, flip it around. If it is measuring 57, then it is acute. That is true. All 57-degree angles are acute. No relationship between the converse and its conditional. Let's look at the contrapositive. Flip it and negate it. If the measure of angle ABC is not 57, then ABC is not acute. Well, that's false, because it could be 42 and be acute. So again, it matches the original conditional. The original conditional is false. The contrapositive is false. Okay, now we're going to switch gears and look at types of deductive reasoning. Let's just go over what a deductive argument is again. You can stop quickly with rubber tires. Mark owns a 10-speed Schwinn bike. All modern Schwinn bikes have rubber tires. Therefore, Mark's bike has rubber tires. Therefore, Mark can stop quickly. Okay, so let's just summarize this argument, just going with basic words. Rubber implies stopping. That's what the first statement says. If you can stop quickly with rubber tires. If you have rubber tires, then you can stop quickly. The second one says Mark owns a 10-speed Schwinn bike. So Mark implies Schwinn. The third statement says all Schwinn bikes have rubber tires. So Schwinn implies rubber. So therefore, Mark's bike has rubber tires. Okay, Mark implies Schwinn implies rubber. And Mark can stop quickly because rubber implies stopping. So there you go. That's a deductive argument. If Mark has a Schwinn, then he has rubber tires and he can stop quickly. So there are two main types of deductive reasoning arguments we're going to be looking at. Law of detachment's real simple. If P implies Q is true and P is true, then Q will be true. So if it snows, then we will go skiing. It snows. Therefore, what can I conclude? Therefore, we will go skiing. Syllogism is a bit more complicated. It's sort of like transitive property. There's like two steps and then a third statement. If P implies Q and Q implies R is true, then P implies R is true. So if Allie hits Sam, Mom will get mad. If Mom gets mad, Allie will be grounded. Allie hits Sam. Therefore, Allie will be grounded. See, it's like got an extra step in there over detachment. Now we're going to look at two arguments here and see if they're true under detachment. Here's detachment again. If P implies Q is true and P is true, then Q is true. If I study, then I will get an A. I studied for 4 hours last night. Therefore, I will get an A. Sounds logical. Let's see. Study implies A. I studied. Therefore, I should get an A. Okay, that's logical. True. Let's look at the next one. If Marcia bakes cookies, the kids will be happy. The kids are happy. Therefore, Marcia baked cookies. When you hear this, it sounds logical. It sounds true, but let's really look at it. Cookies implies happy. Happy doesn't imply cookies. Happy implies nothing. Happy points to nothing. Cookies points to happy, but happy doesn't point to anything. So therefore, no conclusion. The kids could be happy because they won the lottery. Okay, so it doesn't work backwards. All right, now let's see if these are true under syllogism. This is syllogism. P implies Q, Q implies R, then P implies R. So if triangle ABC is a right triangle, then A squared plus B squared equals C squared. If A squared plus B squared equals C squared, then C is a right angle. ABC, triangle ABC is a right triangle. Therefore, C is a right angle. So let's map this out. A right triangle implies Pythagorean theorem. Pythagorean theorem implies C is a right angle. Right triangle. We know it's a right triangle. Therefore, if you just ignore the Pythagorean theorems in the middle, you get right triangle implies right angle. So that logically makes sense. That's true. So let's take a look at this one. The more wordy they get, the more confusing they get. California residents pay state income tax. If Jan moves to San Diego, she will be a California resident. Jan pays state income tax. Therefore, Jan moved to San Diego. So again, I'm going to map this out. California implies tax. That's the first statement. Second one, if she moves to San Diego, she will be a California resident. So San Diego implies California. Tax, therefore, just because she pays tax, tax doesn't point to anything. Tax doesn't point to California, so there's no conclusion here. Just because she pays tax doesn't mean anything. So false. Okay. If Jerry goes on a diet, she will lose 10 pounds. If she loses 10 pounds, she can be a size 7. Jerry lost 10 pounds. Therefore, Jerry went on a diet. So, diet implies losing 10 pounds. Losing 10 pounds implies size 7. She lost 10 pounds. Well, you can conclude that she's a size 7, but you can't conclude she went on a diet. So this is false. But if we look at the same argument again, and then we say we're going to conclude she is a size 7, then it works, because diet implies -10, -10 implies size 7, and -10 implies that she's a size 7. But this is not true. I know it looks like syllogism because it's 3 steps, but the first step isn't even needed. You don't even need that statement to make this true by detachment. So it's true, but it's true by detachment. -10 implies size 7, -10, therefore size 7. Okay, let's just quickly review the differences between detachment and syllogism. Detachment is real simple. A implies B. A is true, therefore B is true. If I run, my leg hurts. I run. Therefore, my leg hurts. Simple. Syllogism a little more complicated. A implies B, B implies C, A, therefore C. So, if it rains, traffic builds. If traffic builds, I will be late. It rains. Therefore, I will be late. There's an extra step there in syllogism. I want to warn you about a tricky situation you sometimes see on tests. What they'll do to you is normally you get A implies B, B implies C, A therefore C in syllogism, right? But sometimes what they do to try to trick you is they put B implies C first and then A implies B. So they switch those two first. And it's still a logical argument because the first statements, it doesn't matter what order they're in. If A implies B and B implies C, then A implies C. So here's an example. If I cheer, my team wins. If I go to the game, then I will cheer. I go to the game. Therefore, my team wins. Let's map it out. Cheer implies win. Game implies cheer. I go to the game. Therefore, game implies cheer. Cheer implies win. We should win if I go to the game. So that's logical, but it's sort of tricky because they flip the first two statements. And here is your mistake of the day. That is not Batman. All right, have a good one. I will see you soon. Talk to you next time.